So here we are in section 12.2. Section 12.2 is called stoichiometry. And stoichiometry is just taking an equation and treating it as a recipe. So if I want to make a certain amount of ammonia, I'm going to look at my recipe and find out what the ingredients are, find the right ratio those combine in, and mix them together. Now before we go any farther, let's review yesterday's important things. The ratios for 1 mole. What does 1 mole equal? And these are things you need to have memorized. Okay, so if I say, what's the volume of 1 mole? It's always 22.4 liters. And that's only for a gas. If I say, what is the mass of a mole? Well, 1 mole, the mass of that, is in grams. How many grams? Well, it depends. Depends what the element is. Okay, the only way I can figure out the mass of every single element is to go to my periodic table. And I look it up, and it'll tell me how many grams it is. What about the amount? How many things are in 1 mole? Well, there's always Avogadro's number of things. Alright, these 3 ratios you need to memorize if you haven't already. And of course we can make them as a fraction, which we will do. That's how we often use them. It doesn't matter what goes on the top, what goes on the bottom. Those things are equivalent, so we can do either one. Now remember, yesterday we introduced the mole ratio. Now a mole ratio is just what ratio do things combine in. Okay, when you're looking at colleges, there's going to be some colleges that have a ratio of 3 guys for every girl. There's other colleges that have a ratio of 3 girls for every guy. That's all we're looking at with the mole ratio. How do things combine? What ratio do they combine in? And remember, we said yesterday, there's obviously a 1 in front of here. I like to bracket the chemical formulas just to separate from the coefficients. Okay? And a mole ratio is just putting the word mole in between there. So if I want to write a ratio of nitrogen to hydrogen, well, I have a 1 in front of here, so that means I have 1 mole of nitrogen for every 3 moles of hydrogen. And I could do many different ratios. I could do a ratio of NH3, ammonia, to hydrogen. And it doesn't matter right now which one goes on top, but I'm going to start with this one. So if I tell you, make me 2 moles of NH3, 2 moles of ammonia. Well, you're going to need 3 moles of hydrogen. Someone asked, do I reduce these if I can? Obviously, these you can't. Do not reduce these. Okay? It just leads to mistakes. It's not really going to help you. It'll get reduced in the long run. So don't worry about reducing if that ever comes up. All right, so these are some mole ratios. And we could do more of them, but we don't need to. That's enough for now. Now what we're going to do is we're going to use those mole ratios. All right, so we're going to have some quantities. We're going to have some problems here. Now what I have here is the 3 times when everything is always equal to 1 mole. And we started this slide with this. That many things in 1 mole, that many liters in 1 mole, and some known amount of grams in 1 mole. Okay, always 1 mole. Remember, the only time you don't use 1 mole is if you're doing a mole ratio. These you need to memorize. I've put them on every slide just for easy reference for this lecture. But now when you get to the question, just figure out what are we starting with and what are we trying to figure out with. Okay, how many moles of ammonia are produced when 0.6 moles of nitrogen reacts with hydrogen? Well, we're starting off with 0.6 moles. We're trying to figure out how many moles of something are produced when we have that. So remember the process says we're going to start with step number 1 is to write the given. That's step number 1. So I have 0.6 moles of nitrogen. And I know that's my formula there. Okay, write the given. Now I'm trying to figure out how many moles of ammonia. That's what I'm trying to get to. So I don't have that. So my second step in the process, after I write the given, well, I don't want the given. So I'm going to take the units and put them down here. The number never transfers down. So I don't want moles of nitrogen. Well, what am I looking for? I'm looking for moles of ammonia. Well, I can change moles of one thing to moles of another by using a mole ratio. So my equation says 1 mole of nitrogen will give me 2 moles of NH3. Okay, so I got 2 moles of NH3 for every 1 mole of nitrogen. I've just expressed that as my ratio. And I know I put NH3 on the top because that's what I'm looking for, NH3. So now I cross off my like units just like we've done before. Moles of N2 cross off. And now I can multiply my 0.6 times my 2, and that's going to give me my answer. And I always want to check. That's my answer. The question says how many moles, so I know I've done something right. Alright, we're just using a mole-to-mole ratio here. Alright, if you feel comfortable, try this problem. It's the same setup as the last one. So you can pause it and work it out. If you're not ready to try it, just keep following along and I'll work it out. Trying to get the old timer so I can see. Alright, so how many moles of aluminum are needed to form 3.7 moles of Al2O3, aluminum oxide? So my first thing I'm going to do is I'm going to take the given, 3.7, that's my starting point. Okay, so I'm just going to write the given. Now I don't want moles of Al2O3, so my next step, without even thinking about it, I just take what's down here, and on the top I'm going to put what I want to change it to. Well, I'm looking for moles of aluminum. So I'm changing moles of one thing to moles of another, and I can certainly do that. So I put what I want on top, which is aluminum, and I take that number right there, 4 moles of aluminum. My Al2O3, I just go to the same formula, and I take that number there. Okay? Back when I said don't reduce it, that's what I'm talking about. Don't reduce that. No point. Now I can just put in my calculator 3.7 times 4 divided by 2. I'm left with moles of aluminum. The question says how many moles of aluminum are there, so I know I did something right. Alright, go ahead and pause this one and work out this problem right now. So this is a similar setup to the last one. Start with my given. Now I don't want the given, so I'm going to take it and put it down there. Not the numbers, just the units. Well, what's it asking for? It's asking for moles of oxygen. Well, we know we can go from moles of one thing to moles of another. We know it's O2 because it tells us right there. There's O2. Now I have my moles of aluminum to moles of oxygen. I take my numbers from here. So aluminum has a 4 and oxygen has a 3. I'm going to cross off my like units, and I'm going to multiply and divide that out. Whoops. And again, moles of O2, moles of oxygen, so I'm done. Okay, go ahead and work this problem out. It's similar. Again, I'm going to start off with my given. It's easy to find the given on these problems because there's only one number there. So I have some O2. I don't want O2. So my next step is to take the units, transfer it down there so I can cancel it. Okay, I'm looking for moles of aluminum oxide, Al2O3. Now I'm going from oxygen to aluminum oxide, and I take my numbers from here. 3 O2s, 2 Al2O3s. Cross off my units that are similar, multiply and divide that out. And again, how many moles of Al2O3? That's what my answer's in, so I'm done. Alright, let's try a different type of problem. This one's asking for grams. Again, the process is always the same. Okay, I'm starting off with 5.4 grams of hydrogen. So again, my first step is to write the given. My next step, since I don't want hydrogen, put it on the bottom. Now what can I change grams to? Well, I can change grams to 1 mole. How many grams are in a mole? I better go to the periodic table. And it is H2. So hydrogen, I look it up, it's 1 gram for hydrogen. There's 2 hydrogens, so 1 plus 1 is 2. 2 grams for 1 mole of hydrogen. I'm going to cross off those units as I go. I better add up my hydrogen up here. Grams of hydrogen to moles of hydrogen. Alright, so I don't want moles of hydrogen because it says grams of NH3. I need NH3, so I got to get out of hydrogen. So I'm going to take my units here, since I don't want them, and put them down here. And I'm trying to get to NH3. So to change from one chemical to another, I'm going to do a mole-to-mole ratio. Okay, that's the chemical I want. Now from here, there's 2 moles of NH3 for every 3 moles of hydrogen. And cross off my like units. So now I'm in moles of NH3, but I want grams of NH3. So I need to do another step. So I'm going to take what I don't want, put it down here. Now I can go from moles to grams. And to get my grams of NH3, well, grams is always 1 mole. I go to my periodic table. I'm going to add up those pieces, and I get 17 grams. 1 nitrogen, 3 hydrogens. Cross off my like units. I'm in grams of ammonia. That's what I want, so I'm done. Now I just have to multiply it all across. So everything on top gets multiplied by everything on the bottom. Okay, 5 times 2 times 17 divided by 2 times 3. And if we multiply all of that out, we get a final answer of 31. Alright, I'm going to stop the video. That's the end of part 1.